Welcome everyone. Today we'll explore about the key components of pipeline integrity management. Overview and importance, Introduction to Pipeline Integrity Management. Pipeline Integrity Management or PIM refers to a systematic approach to ensuring that pipelines operate safely, efficiently, and in compliance with regulatory standards throughout their life cycle. It encompasses strategies, processes, and technologies aimed at preventing failures, minimizing risks, and maintaining the structural and operational integrity of pipelines. The importance of PIM lies in its ability to protect public safety, the environment, and company assets. Pipelines transport critical resources such as oil, gas, and water, and any failure can lead to catastrophic consequences including environmental pollution, financial losses, and reputational damage. Therefore, implementing a robust integrity management program is essential for operators to meet legal obligations, reduce downtime, and optimize asset performance. PIM also supports sustainability goals by reducing leaks and emissions, contributing to environmental stewardship. The concept integrates engineering principles, risk assessment, and continuous monitoring to create a proactive maintenance culture rather than reactive repairs. This introduction sets the stage for understanding the key components that make up an effective pipeline integrity management system. Compliance requirements, regulatory framework and standards. Pipeline integrity management is governed by stringent regulatory frameworks that vary by region but share common objectives: safety, reliability, and environmental protection. In the United States, regulations such as those from the Pipeline and Hazardous Materials Safety Administration or PHMSA mandate integrity management programs for hazardous liquid and gas pipelines. Internationally, standards like ASME 31.8S, API 1160, and ISO 55000 provide guidelines for asset management and risk-based approaches. Compliance involves documenting procedures, conducting regular inspections, and maintaining records to demonstrate adherence to these standards. Operators must also implement corrective actions promptly when anomalies are detected. Regulatory audits and reporting requirements ensure transparency and accountability. Failure to comply can result in severe penalties, operational shutdowns, and legal liabilities. Therefore, understanding and integrating these standards into the integrity management framework is a foundational component of pipeline operations. Compliance not only fulfills legal obligations but also builds trust with stakeholders and reinforces a culture of safety. Identifying and mitigating risks, risk assessment and management. Risk assessment is a cornerstone of pipeline integrity management, enabling operators to prioritize resources and interventions based on potential threats. The process begins with hazard identification, which includes internal and external corrosion, mechanical damage, material defects, and operational stresses. Quantitative risk models often combine probability of failure with consequence analysis to determine risk levels. Geographic Information Systems, GIS, and data analytics enhance risk visualization and decision-making. Mitigation strategies include implementing protective coatings, cathodic protection systems, pressure control measures, and operational adjustments. Emergency response planning is also integral to risk management, ensuring rapid containment and remediation in case of incidents. Continuous improvement through feedback loops and lessons learned from past failures strengthens the risk management framework. By systematically assessing and addressing risks, operators can reduce the likelihood of catastrophic events, optimize maintenance budgets, and ensure compliance with regulatory expectations. Technologies for pipeline surveillance, inspection and monitoring techniques. Inspection and monitoring are critical for detecting anomalies before they escalate into failures. Techniques range from traditional visual inspections to advanced technologies such as inline inspection or ILI tools, also known as smart PIGs, which use magnetic flux leakage or MFL or ultrasonic testing or UT to identify corrosion, cracks, and wall thickness variations. Remote monitoring systems employ sensors and SCADA, supervisory control and data acquisition, platforms to track pressure, temperature, and flow rates in real time. Aerial surveillance using drones and satellite imagery provides additional coverage for remote or inaccessible areas. Acoustic monitoring and fiber optic sensing are emerging technologies that detect leaks and vibrations along the pipeline. Data collected from these methods feed into predictive maintenance models, enabling proactive interventions. Regular calibration and validation of monitoring equipment ensure accuracy and reliability. By leveraging these technologies, operators can maintain situational awareness, reduce downtime, and enhance overall pipeline integrity. Preventive and corrective actions, maintenance and repair strategies. Maintenance strategies in pipeline integrity management encompass preventive, predictive, and corrective actions. Preventive maintenance involves scheduled activities such as coating inspections, cathodic protection checks, and valve servicing to minimize degradation. Predictive maintenance uses data analytics and condition monitoring to forecast potential failures, allowing timely interventions. Corrective maintenance addresses defects identified during inspections, which may include welding repairs, sleeve installations, or component replacements. Advanced repair techniques like composite wraps offer non-intrusive solutions for reinforcing pipeline sections without shutting down operations. Maintenance planning must consider operational constraints, safety protocols, and environmental impact. Documentation of all maintenance activities is essential for regulatory compliance and historical analysis. A well-structured maintenance program reduces unplanned outages, extends asset life, and ensures continuous safe operation of pipelines. Leveraging data for decision-making, data management and analysis. Data management is a vital component of pipeline integrity management, enabling informed decision-making and regulatory compliance. Modern pipelines generate vast amounts of data from sensors, inspections, and operational logs. Effective data management involves collecting, storing, and analyzing this information using robust software platforms. Geographic Information Systems (GIS) integrate spatial data for mapping pipeline networks and identifying high-risk areas. Predictive analytics and machine learning models process historical and real-time data to forecast potential failures and optimize maintenance schedules. Data visualization tools provide intuitive dashboards for monitoring key performance indicators. Cybersecurity measures are essential to protect sensitive operational data from unauthorized access. By harnessing data effectively, operators can transition from reactive to proactive integrity management, reducing costs and enhancing safety. Preparedness for incident management, emergency response and contingency planning. Emergency response planning is critical for minimizing the impact of pipeline incidents such as leaks, ruptures, or explosions. A comprehensive plan includes risk identification, resource allocation, communication protocols, and coordination with local authorities. Operators must establish clear procedures for isolating affected sections, deploying containment measures, and initiating cleanup operations. Training programs and simulation exercises ensure personnel are prepared to act swiftly and effectively. Integration of emergency response plans with monitoring systems enables rapid detection and response. Documentation and post-incident analysis provide insights for improving future preparedness. Effective contingency planning not only mitigates environmental and financial consequences but also reinforces public confidence in pipeline operations. Innovation in integrity management, continuous improvement and future trends. Continuous improvement is essential for adapting to evolving challenges in pipeline integrity management. Emerging trends include the adoption of artificial intelligence for predictive analytics, blockchain for secure data sharing, and advanced materials for corrosion resistance. Digital twins, virtual replicas of physical assets, enable real-time simulation and optimization of pipeline operations. Sustainability initiatives drive the development of eco-friendly coatings and leak detection technologies. Collaborative platforms facilitate knowledge sharing among industry stakeholders, enhancing best practices. Regulatory frameworks are also evolving to incorporate risk-based and performance-based approaches. By embracing innovation and continuous improvement, operators can enhance safety, reduce costs, and ensure long-term reliability of pipeline infrastructure. Summary and key takeaways. Pipeline integrity management is a multifaceted discipline that integrates regulatory compliance, risk assessment, inspection, maintenance, data analytics, and emergency preparedness. Each component plays a vital role in ensuring the safe and efficient operation of pipeline systems. By adopting a proactive approach and leveraging advanced technologies, operators can minimize risks, optimize performance, and uphold environmental and safety standards. Continuous improvement and innovation will shape the future of integrity management, making pipelines more resilient and sustainable. Ultimately, a robust integrity management program is not just a regulatory requirement but a strategic imperative for operational excellence.